Good afternoon, everyone. I am Orgopra Banerjee from India, and today I'm going to present the topic application of 2D Qsar and chemical read-across algorithm to predict the androgen receptor binding affinity. So what I mean by endocrine disruptors? So these are compounds which promotes adverse modification in hormonal regulation, and they show various neurological, reproductive, and cardiovascular adverse effects. Now, there are certain endocrine disruptors which are specific to the androgen receptor, and our study over here is to model those compounds using 2D Qsar and chemical read-across approaches with the aim of developing safer chemicals. So this is our workflow where we have collected the data set from EDKB database. We have curated the structure using NIME analytics platform, and then we have calculated the descriptor using AlphaDesc. Now we have divided the dataset in training and test set and performed feature selection using genetic algorithm and best subset selection. Now from here onwards, we have bifurcated our work into two different directions. Firstly, we have developed the PLS model and checked the applicability domain. Secondly, we have deviated from the QSR and applied a novel quantitative read-across approaches. And after optimization of the hyperparameters using Gaussian kernel similarity-based metrics, we have obtained certain external validation metrics. Now, in order to validate our findings in the QSR, we have also performed pharmacophore modeling, docking, and molecular dynamics simulation. And the results are at par with the QSR findings. Now, there were certain compounds whose log RBA value were unreported, and we have predicted them using our prediction reliability indicator tool. So these are the software tools that we have used. The ones at the left are developed extensively in our lab itself. So this is the PLS equation, and these are the validation metrics of the PLS equation, and these are the validation metrics of the read-across. Now you can see here that the validation metrics in read-across is slightly better than what we have obtained in the QSAR process, and which is better than what the other scientists have obtained over the years using 3D QSAR techniques. So this is the VIP plot where the descriptor SSSCH has been found to be the most important, and this signifies the presence of a steroidal nucleus in our data set, and compound number 23 has a higher SSSCH descriptor value, and compound 148, since it does not have a steroidal nucleus, it has a low SSSCH descriptor value, and thus this moiety induces hydrophobicity and thus produces receptor binding affinity. NCCONJ descriptor, this generally signifies this enone moiety of the ring A of the steroid nucleus. Now this ketone group over here, it performs hydrogen bond acceptor with the arginine residue of the androgen receptor, and thus it exhibits more toxicity. N% signifies the presence of a nitrogen atom in the molecule, and as stated by Zhu et al., nitrogen atoms are able to perform hydrogen bonding with the receptor residue, and compounds having nitrogen atoms, they are more prone to show toxic effects than compounds which do not have nitrogen atoms. Similarly, F08OF descriptor means the frequency of O and F at a topological distance of 8, which generally means the presence of a highly electronegative atom in the case of fluorine, and it performs again hydrogen bond interaction with the receptor residues. Now, in the structure of hydroxyflutamide, due to the presence of this CF3 group, it exhibits a higher log RBA value as compared to triphenylethylene. Again, if we look at the first two structures, the structure promegastrone, it is slightly bigger than the N-propyl 4-hydroxybenzoate. So again, bigger structure signifies that there is a high log P value and thus higher log RBA value as well. F10CO descriptor, this means the presence of CNO at a topological distance of 10. So this descriptor generally depicts the presence of a polar group in the form of an OH group or enone group or carboxylic group. So in the structure of 6-hydroxyflavone, due to the presence of this OH group, it induces polarity and leads to faster elimination from the body, thus leading to lesser receptor binding affinity. So this descriptor contributes negatively to our model. So if we summarize the whole thing, descriptors like hydrophobicity, they are able to perform better receptor binding affinity, while features like electron richness and polarity, they are able to reduce the receptor binding affinity. So these are our results from a pharmacophore modeling, docking, and molecular dynamics simulation. But again, you can see that this ketone group is able to perform hydrogen bond acceptor with the arginine residue of the receptor, and this OH group present specifically at the 17th position of the steroid nucleus, it performs hydrogen bond donor with the asparagine residue of the receptor, and this steroidal skeleton, it is a hydrophobic moiety, and thus it exhibits more toxicity. Now, if we compare our work with the works that have been done previously, we have used 2D descriptors while the others have used 3D descriptors and performed conformation analysis and alignment. So we can say that our model is reproducible. Secondly, the difference between R square and Q square values in our case, it's very low as compared to the other two cases. So again, our model is much more robust than the other two models. And lastly, the predictive ability of our model is okay as per the requirements of the external validation matrix to be able to be greater than 0.5. So if we summarize the whole thing, our model is better than the other two works which have done 3D QSR, specifically the COMPA technique. So lastly, I like to conclude that a regression-based 2D QSR model was developed, which is robust, predictive, and avoids 3D QSR and conformation analysis. And the model developed should be a useful tool to predict the androgen receptor binding affinity. Chemical redact cross was also tried, and the results were obtained were even better. And features like hydrophobicity, hydrogen bond acceptor, and hydrogen bond donor present in a molecule are able to perform receptor binding affinity as supported by a pharmacophore modeling, docking, and MD simulation. Thank you.
Okay, thank you. We have several questions. How the applicability domain was determined? The question from Vladimir Poroykov.
So applicability domain was determined using the SimCAP software. We have used the DMODX applicability domain approach.
And the question from Pavel Polishuk. Why did you use two feature selection approaches?
Sir, firstly, we have done the genetic algorithm and we have extracted certain descriptors and then best subset selection. So this is a special tool which generates all possible models from any combination of descriptors. So this is a very useful tool to determine the best model from a particular set of descriptors. So here, that's why we have used best subset selection.
Yes, and the question from Henoch Shenderovitz. What was the size of your data set? The size of your data set.
Sir, I didn't hear. Once more.
Do you hear me?
Yes, sir. So please repeat the question once more.
Yes. What was the size of your data set? How many compounds?
Yes, we had 103 compounds in the training set and 44 compounds in the test set. Which again is a lot more than one of the works I have shown over there, because they have taken a lot, I think 28 compounds and done the 3D QSR and COMPA technique. The other data set had similar compounds, but they had a much larger compounds in the training set itself. So which should be able to generate a higher internal validation matrix, but that didn't happen in case that it didn't even happen. So we have used lesser number of descriptors as compared to one of the models, lesser number of compounds, I mean, and still we had a higher internal validation matrix as well as external validation matrix.
Yes, and why did you not use 3D descriptors in your QSAI analysis? Did you use a validation set during hyperparameter optimization of your reader crosswalk?
Yes,
the question from
firstly, let's answer the 3D QSR. So we have avoided 3D QSR because it involves conformation analysis and alignment, and our main motto is to develop a model which is easy and which can be reproducible. So 2D QSR approach and use of 2D descriptors, they are reproducible approach, while 3D QSR is not. And the second question, please repeat the second question once more.
How did you choose the number of LVs in your PLS analysis?
Okay, so we had 8 descriptors initially from our MLR model. So we have run with the 7 latent variable once the PLS, and then we have found the particular latent variable which generates the highest value of Q² LO value, that is Q² leave one out value, and that happens to be our optimum latent variable in our QSR model.
And from Henoch Shenderovitz, one more question. What did you learn from the molecular dynamics simulations?
Sir, it was actually a collaborative work. So it has been done in Jackson State University. So I don't know much, but there's something I know that it is used to validate our docking. So it has been run in 100 nanoseconds, and it has been checked to if the stability of the receptor binding interaction with the drug is possible or not.
Yes, and question from Timur Majidov. do you rely on the coefficient value for interpretation of descriptor importance?
Coefficient value, yes, sir. In the PLS tool itself, it gives the coefficient as well as the standardized coefficient. So from there onwards, we can identify which are the descriptors or which are the features that are most important in the model itself and for the molecule. And we have also done the variable importance plot as shown here, and we have identified the descriptors that contributes.
Yes, and continuation of this question. Do you think that in this case, the scale of descriptor will influence on the descriptor importance?
Thus, we have used these two.
The scaling. What about influence of scaling of descriptors?
Yes, it can be done, and that's how probably the standardized coefficient comes. And in the algorithm of read across itself, it is the scaling is done for the Euclidean distance based predictions, and even for the Gaussian and Laplacian kernel based predictions also.
Yes, so thank you very much. It was the last question.